Under sequence composition in the report, you can find this plot here. So this plot helps you to spot the presence of contaminants in the library. On the x-axis, you got the cycles or the positions in the read. On the y-axis, you see percentages. So percentages of each base, because every color represents a base here. So yellow is C, blue is A, red is G, and green is T. So for every position, you see the percentage of each of these bases. So you don't expect that the percentages of these 4 bases are equal for every position, because this depends on the GC content and the genome of the organism that you work with. But in a diverse and random library, you do expect that the chance of seeing a C is equal in every position in the read. So in other words, what you expect here are flat lines. The plot is always a bit peaky here at the left side for the first 10 to 15 cycles, and that's because the sequencer is doing some internal calibration during these cycles. However, if the plot stays peaky across the entire read, it likely means that one specific sequence occurs a lot in your file, distorting the plot. And that's contamination. Sometimes you can even guess the sequence of this contaminating sequence by just reading the pattern in the peaks here. So in this example, if you start at cycle 30, you see that we get a G, another G, and then something that is either an A or a T. Then we get another G, then we get an A again, another A, and then something that is either an A or a T, and so on. Contamination in the library is often caused by adapter dimers. So we will come back on this later. When you scroll down here, you end up with this plot. This is also an important one. It's closely related to the previous plot, and it shows the distribution of the GC content across the reads. So for each read, the GC content is calculated, and then we built a histogram of all the GC contents of all the reads, and that's what you see here. So in a diverse and random library, you should see a smooth, symmetrical, and bell-shaped distribution. If you spot a big spike in this plot, that's a red flag. It usually means that there is one single sequence that occurs many times in the file, which skews the distribution. And then the GC content of that particular sequence creates the spike in the plot. So also here, you will see if there's a contaminating sequence in your FASTQ file.